Hello everyone, welcome to my YouTube channel, and today we are going to perform image classification using deep learning models. And for that purpose we are going to be using AlexNets and ResNets. We'll take random pictures from the internet and we'll store them on our Google Drive, and for the sake of this video I'm going to be using Google Colab. But you can also download this notebook and perform everything that I'm going to be doing here in your Jupyter notebook on your laptops or computers. But of course, for that purpose, you're going to have to install the dependencies that we're going to use in this tutorial. But if you are going to use the Google Colab, then keep in mind that all the dependencies are already installed on it. I will upload the notebook on my GitHub. So this is my GitHub right here. You can just go ahead and follow me here and also access all the repositories that I've worked on through here. And don't worry, I'm going to be leaving the link of my GitHub in the description section, so you can just go there and grab the link and access these repositories. And other than that, I have also created a Facebook group where I will be uploading all the materials and latest upcoming videos related to machine learning, deep learning, Python, and computer vision in general. So go ahead and join this community on the Facebook, and I'm going to be leaving the link of this group in the description section as well. So without further ado, let's just dive into this video. Okay, so we're going to be performing image classifications using AlexNet and ResNets, which are deep learning models, and we're going to be doing single level and multi-level classifications with these resources. So we can just go ahead and import the dependencies that we're going to be using in this project. And if you're using Jupyter Notebook, you'll have to install some of the dependencies. For example, we're going to be needing matplotlib to plot our images. So if you don't have installed in your laptop, you can just go ahead and use this command in your Jupyter Notebook, and with that, hopefully you'll get your matplotlib in your laptops. Remember, when you write this command inside this notebook, what you'll have to do is use this exclamation mark before that, and when you'll execute this command, then your matplotlib will be installed in your computer. So but for the sake of this video, we're going to be using Google Colab. So and Google Colab comes with all of these resources, so that we don't have to install them. So we can just go ahead and skip this part right here, and of course we're going to be using some images. So for that, what we'll do, we'll import PIL, and from PIL we'll import images, because we have to read images, right? So what I'll do with this image, I'll use open method, and in this method what I'm gonna do is I'm gonna give it to the path where my image is stored. So I've stored my image inside of my Google Drive. So I have to connect my Google Drive to this Google Colab. You can just go ahead and click right here, and it will ask you to whether if you want to connect to Google Drive. So you just go ahead and click on that button, and it'll take a few seconds, and then you'll see your Google Drive right here. So once we get this drive here, we will just navigate to the folder where we have stored our image, and in this case I have stored this image in this image classification with deep learning model folder, and I'll just go ahead and click here, and here you can see I have two images. The first one is cat.jpg, second one is cat and dog JPEG, right? So this first image we're going to be using it for single level classification, and the second one we're going to be using for multi-level classifications. And this right here is a text file which contains 1,000 classes, 1,000 different classes that we can find the results for. So we'll dive into this later. Right now I'm going to just go ahead and right click here, and I'll copy this path and I will paste it right here. So you're gonna see that all of the address of this cat JPEG will be printed out here, and we're gonna be using a variable in which we'll store this image. So let's call that input image. Okay, Cool. So now what we have to do is we have to plot this image. So for that we're going to be needing our matplotlib, right? So what I will do, I will just write import matplotlib dot pyplot, and what I'll do, I'll just go ahead and give it an alias. Let's call it plt. Right, so I'm going to be using this dependency to plot my cat.jpg, right? So what I'll do, I'll just call my matplotlib, and I'll use imshow method, which is written this way, and in this imshow method I'm going to be giving this variable in which I have stored my image, right? So I'll just go ahead and paste it here, and I will execute this cell. So now you're going to be seeing in a couple of seconds. So here we have our image that we selected for this project. Here you can see this is a cat. This is a very pretty cat actually that we're going to be using in this project, and we're going to be classify or we're going to be using a models which will classify that what animal it actually is, whether it's a cat, it's a dog, or it's a sock. For example, if it's it's a car, or it's a jet, or it's a boat, because remember we have 1,000 different classes. Actually we have a very extensive database that we're going to be looking into. So moving forward, we'll just go ahead and perform certain steps that we always have to do before feeding the input to our models. So always remember that before feeding your input to the model, you have to transform it, or you have to pre-process it. Okay, so in this case we are using images, so we have to transform these images according to the needs of your deep learning models, which in this case is AlexNet or ResNet, right? So first of all, we're going to be transforming these images. So for transforming these images, we're gonna create a transform which has all the characteristics that our ResNet or AlexNet model is going to need, right? So I'll just go ahead and I will write here, let's create a cell, and just give it a heading that we're gonna be creating a transform, and let's just leave it right there. So what we'll do, we'll import our transforms, and we'll import them from our touch vision. So remember I told in the start of this video that these models are pre-trained, and all of this comes in touch library, right? So we're gonna import those transforms as well from the touch vision. So we can just write I just made a little mistake here. We have to write from touch vision import transforms, right? Okay, so moving forward, what we have to do is we have to compose a transform, right? So we'll use compose method, and we use that method on transforms, obviously. So we'll write compose. Remember here C is capitals because Python is case sensitive, so you have to be careful about this. We're going to just go ahead and create a list here because we have we had to create a list. Let's say it is this. Okay, we have to create a list which will contain different types of characteristics that our transforms gonna need. So first of all, what we have to do is we have to resize our image. So we'll just go ahead and write transforms dot resize, and in this resize we're gonna give the size that we want our image to transform into. So we'll write 256 here because of this command or this line right here, the transform will convert this image into 256 by 256 image. Okay, so after that what we have to do is we have to center crop this image. So I'll just go ahead and I'll copy this. Okay, I'll just go ahead and copy this, and here I will write center crop, and here I will write 224. Okay, So after that, what we have to do is we have to convert this image into tensor. So tensor is actually, in simple words, is a data structures, or you can call it it as a multi-dimensional arrays that represents our images, right? So for that, what we have to do is we just have to call a method which is called to tensor. Okay, so after that we have to normalize our input. Obviously, just like every other machine learning model or deep learning model, we have to normalize our input. So for that we will use a method called normalize. And the funny thing is, they have also defined the normalized characteristics as well, because we normalize our data based on two things, the first one is mean and the second one is standard deviation. So we also have certain values for these ResNet and AlexNet that we can feed our transforms to. So we can create mean, and here we have a couple of values. The first one is 0.485, and the second one is 0.456, and the third one is 0.406. So these are the values that we are already given for the sake of these models. I mean, these are predefined, and the models take the normalization in terms of these mean and these standard deviation values, right? So you don't have to be worried about this too much. You can just go ahead and copy these values and use it in your program or in your project. You can just go ahead and write this here, and 0.225, right? Okay, so we're almost done with transforms. And what we can do is let's just do this, and yeah, so now our cell is pretty clean, and what we can do is we can just go ahead and run this cell. So that means we have created a transform, but we had to store this transform that we just created into a variable. So let's call it a variable named transform. So now we have stored our transform into this variable right here. So what we're gonna do is we're gonna feed this image, or the variable in which we stored this image, to this transform to convert this image into a desirable format, right? So what we can do is we can just go ahead and feed our image to this transform, and let's just call this transform right here. I'll just go ahead and rerun this cell, and after that what I'm gonna do is I'm gonna write here transform, and then I'll write the name of the variable in which I stored my image, right? So it was input image, right? Here you can see we have this input image. Okay, so okay, we have a little mistake here. Image was only once. Okay, so we have fed our input image to this transform, right? So what we're gonna do is we're gonna store this value, or the result of this, into a variable. Let's call it as transformed image. Okay, so now this variable right here have the image that has been transformed. What we can do is we can just go ahead and analyze the shape of our transformed image to see what we have done so far. So we can just go ahead and run this cell, and in the next cell we can just go ahead and write transformed image, and we can use a method called shape. Okay, so we can just go ahead and execute this right here, and here you will see your image has been converted to this format. So now we have a list of 3 integers here. The first one is 3. So if you focus on this image right here, you'll notice that this is a colored image, right? This is not a grayscale image or black and white image. So the colored images always have 3 channels, red, green and blue, what we call them as RGB. So this pic is a RGB pic. Because it has colors, and all the colors are made up of 3 colors that are red, green and blue, right? So that is why we have 3 here written, because we have obviously 3 channels. And this is the 224 by 224 image. Remember, we center crop that image with these values, right? So our image right now has these dimensions and this number of channels. Okay, now after transforming this image, what we have to do is we have to convert it into a batch format. So whenever you feed your input to the model, first what you have to do is you have to convert it into a batch format, right? So for that we're going to use a method from Torch. It's called unsqueeze, right? So for that we're going to be importing the Torch library here, and after that what we can do is we can just call a Torch, and from that Torch we can just call unsqueeze, and in that method what we can do is we can give our transformed image, okay, sorry, image, and here you will write this 0 here. With this what you can do is when I'll print out the result of this unsquared method, you will see that it will give you another dimension here, and that will start from 1. So we have just defined that start from 1 value after 0, right? What we can do is we can store the result of this unsqueezed value into input image, or I'll say input image batched. So let's just name this, because after this unsqueeze method this image is gonna be converted into batch format, right? So what I can just do, I can just go ahead and execute this, and in the next cell what we can do is we can check the shape of this batched input as well. You can just write shape here, and we'll use print function to print it, and we can just execute this cell, and here you can see another dimension has been added to this input, right? And you can see it has a value of 1, because we told it that start from a value that comes after the 0. Okay, so now we have 4 dimensions. These two actually gives us the dimension of the picture, which is 224 by 224. Then it's gonna have 3 channels, and it tells us that this is the first batch. I mean, it's converted into the batch form, right? Now what we can do is we can actually import our pre-trained models, and we can feed this input to our models, and then find out that what result we get after those models are done processing. So let's just go for ResNet. I mean, first of all we'll go for ResNet, and after that we can go for AlexNet, right? So let's just go ahead and write here. Now I told you that these models are actually pre-trained, so they are also available in our Torch Vision library. That is why we can just go ahead and import these models from there. So we can write Torch Vision import models. Okay, if you want to figure out that how many models that you have in Torch Vision, you can use this dir method, and you can write models here, and you can execute it, and here you will have a complete list of all the models that are available in Torch Vision, right? So we have here different models like ResNet, and here we have different variants of ResNet. Then we have ResNets, then we have ResNets, and as you can see that there are different variants of all these models, and here you have VGG, and all swine B, swine S, swine T, and swine transformers, and just like that we have VIT. These are vision transformers. So from here you can import your ResNet, right? So here you can see these are the ResNet variants listed here. You can see we have ResNet 50, we have ResNet 34, ResNet 18, ResNet 152, and ResNet 101. So as the number increases with these ResNets, the computation time will obviously gonna be increasing, and obviously because of that the accuracy of the model will increase as well. So what we can do is we can just go ahead and let's import this variant here, ResNet 101. So for that, what we can do is we can just go ahead and call models, and from models we need ResNet and we need ResNet 101, and we will tell the model that we need you pre-trained. Okay, and of course, just like everything else, we have to store it into a handle, and that is called a variable, and we can call that variable ResNet. Okay, so what we can do is we can take our batched input and we can feed that input to this variable, which has this ResNet model, ResNet 101. Okay, so before doing that, what we have to do is we have to activate the evaluation mode of this model. So for that, we can just use our ResNet, and we can use a method called eval, right? And after that, what we can do is we can simply call our ResNet model, and we can store our batched input into this model. So let's just copy this from here so we don't have any typing error in the name, and we can just go ahead and write this here. Okay, so it's as simple as that. But again, just like everything else, you're gonna be storing the output of this process into a variable. Let's call it output. Okay, so let's just go ahead and execute this. Now obviously it's gonna take a couple of seconds because it's gonna be processing, and in the processing, the model has a couple of layers of neural networks, right? Okay, so it's done processing. What I'll do, I'll just go ahead and write the name of the result here, and you can see all the results I mean after using this model. So we have all these values that are either negative or positive, and then we have this e to power let's say minus 0.1, then we have e to power 0, and we have e to power, you know, different. So these are random values that we are getting. So basically these are all the values against all these 1,000 classes that we're going to be looking into, right? So it's actually giving us the prediction that, okay, look, I am this sure that the answer is this class, or I am this sure that the prediction is going to be this class. Okay, so what we have to do is we have to convert this value into percentage, obviously, but before that, what we need here is that we read actually the name of the classes from this file, and then we can find a percentage of a single maximum class, or a single value that gives us the maximum value, and according to that value we can extract the name of the class from this I would say this file right here. So for that we have to import this file, or we have to read this file in our Jupyter notebook or in our Colab notebook. So for that we can use a simple code which is called with open. So obviously we're gonna be opening, and here we will give the address of this file where it's present right now. So I'll just go ahead and copy and paste this, and we'll give it an alias. Let's call it class file. Okay, so we are reading this file or opening this file as class file, and after that what we're going to be doing is we're going to read this file line by line. Okay, so for that, let's just go ahead and write a loop here. We can say that for each line in this document, and this line is obviously is going to be inside our class file. And what is our class file? The alias that we gave our file to, right? So let's just go ahead and copy this and paste it here. Okay, we're gonna be writing the loop for it, right? But what we have to do is in this loop, obviously there's gonna be some sort of body of this loop as well, right? So instead of writing this into another line, what we can do is we know that our Python is pretty flexible, so we can write the body of this loop in this same line, right? So what we have to do is we have to simply strip all the I would say all the spaces that are present in each line, the first one or in the or the last ones, right? And you can write this this square brackets here. So that is how you have written the entire loop in one line. And obviously, just like anything else, what we're gonna do is we're gonna store each line into a variable, and let's call that a variable as I would say image net classes. Let's call it that. Okay. Yeah, just go ahead and run this, and hopefully we are gonna be reading our file. We'll just go ahead and use these values. We will extract the maximum value, and then we'll convert that value into a percentage prediction. And after that, we're gonna be extracting the class names from these lines, which are stored against that prediction that we are going to make, right? So let's just go forward towards predicting the output index of the class. And so for that, this is a simple code that you can write. So we'll be looking for predicted value, and for that we're going to be importing a max method from Torch. And in that, what we can do is we can just go ahead and write this. Now what's it's gonna do, the max method actually gives us the maximum value that we have inside of an array, right? Of course we are applying this to this output, and this output contains all these values. So at the end of this process, this max method will actually give us the class that has the maximum value. Okay, so we'll just go ahead and, for example, we'll write predicted, and we'll execute this. So you can see that as a result we have this class that had the maximum value. Okay, that is why we use this maximum method, because we had to predict the class which had the maximum value. So because that class is stored in this predicted, so that is why when we wrote this, then it printed out. But right now it is in the form of array, right, in the form of tensor. But we have to convert it into a percentage, right? I mean, we have to find out that how certain the model is that this class is the right answer. And we also have to convert this into an integer. We don't want this into an array. So what we can do is we can just go ahead and uncomment this out, and we can write Torch. And because we have to convert it into a percentage format, then we have to use softmax. Now softmax is the activation function that converts your prediction I mean in the range of 0 to 1, 0 being the least confident and the 1 being the most confident. Okay, so if your value is closer to 1, then that means your model is pretty sure about something, and if it's closer to 0, then obviously it's going to be meaning that your model is not sure. Okay, so what we can do is we can just go ahead and feed your output to this softmax, and what we can do is we can use dimension is equal to 1, and here what we can have is your index 0, and after that what we want is to convert that into percentage. Okay, what I have done here, as you can see, this 285 is written into array format, right? So let's say we have more than one values that have the maximum value. So that means this array is gonna have more than one values in it, right? And what we want is the most confident value, right? Or the value that has the most confidence. So that value is going to be the first one in this array. So for that, what we are doing is we are just calling this value that is stored against this 0th index from this output, and then what we are doing is we're just simply multiplying it with our I would say 100. What we are doing is this softmax function will actually extract the value or the percentage or the confidence level against this class or against this integer or against this value from all these values, and then we will use that value to find a percentage, and we will multiply that value with our 100. Okay, so what we can do is we can just go ahead and store this value into our variable, just like any other thing that we're gonna that we have discussed in this project, and let's call the variable as percentage. Okay, now what we can do is we have to print out the class and the class number, the class name, and the percentage, that how certain this model is about something. Okay, so for that what we can do is we can write our print function, right? And in this what we call predicted, obviously, and from predicted we call our first element. So predicted has this value right here, right? So remember I told you that what if we had multiple values that had the maximum prediction, maximum predictions, right? So in that case we're going to be having or we will have more than one values in this array, right? And we want to extract the most confident value, right? And that value is present on the 0th index. So for that what we can do is we can simply call the 0th value from this predicted array, and what we can do is we can feed this number in other words we can feed this 285 number to our this variable, right? So what we'll do, it will check in each line for in other words it will just go to this numbers line that will be stored in this variable, right? And it will print out the value which is stored against this number in this line. I will let me write this here, and after that we can open this file and we can see how the values are stored in this file. We can just simply go ahead and copy this, and after that we can paste it right here. Okay, so let's just go ahead and open this file, and this is the text file. Now you can see it's actually stored in dictionary format, and against each number we have a class name, right? Against each number we have a different class name. And remember I told you that we have almost 1,000 classes stored in it, right? So you can just go ahead and explore this file, and you can see that we have around around 1,000 classes. Okay, obviously we started from 0th index, so the 1,000 values index is going to be 999. Okay, so I'll just go ahead and close this window here, and what I'll do, okay, now this will print out the class number and what is stored against that class, right? But we also have to print out the percentage of that predicted value. So for that what we can do, we can concatenate and we can write, or simply just go ahead and copy this and paste it here, and this, and simply the same value that you used for reading from the file, just paste it here and go ahead and execute this. It gave us I would say our class number, and it gave us a class name. So the model is saying that it is an Egyptian cat, and here it's giving us percentage, but it's giving us in tensor format. But we don't want it this way. We want it into the integer format. So for that what we can do is we can write item method here, and again execute this, and now this value has been converted into integers. So right now our model is 84% sure that this image is of Egyptian cat. So that's everything that you have to do to train a model and predict a value after feeding a random image from the internet to that model. So right now what we did, we used a random picture of a cat, and after some pre-processing we fed that image to the model, and as a result it gave us the prediction. It told us that the model is 84% sure that the image of a cat contains Egyptian cat. Okay, So it is stored against this 285, and remember this 285 actually came from this predicted value that our model predicted, and that was stored in our output, right? So far we have done single label image classification of an image using a ResNet model, and next what we have to do is we have to do multi-level or multi-label classification as well using ResNet model, and we have to perform all these things using Alex model as well, or AlexNet model as well. Okay, so I think that is it for this video. In the next video of this series, we're gonna be performing multi-label classification, and we are or later on in this series we're gonna be using AlexNet model to predict, and after that we will compare the performance of the models, that which one of these is the most accurate one. Okay, so if you like this video, if you learned something significant from this video, just go ahead and click on that subscribe button, and also click on that bell icon so you get the notification whenever I upload fantastic videos like this. And if you have any question, or if you like to add something, just feel free to write your review in the comment section of this video, and I will be more than happy to respond. So stay happy, stay shining, goodbye.